One we plan to cover in detail. Selection sort.
Mhm.
What's the idea here?
Selection sort also divides the list conceptually into sorted and unsorted sections, but its strategy is different.
How so?
In each pass, it scans through the entire unsorted section to find the absolute smallest element remaining.
Finds the minimum. Okay.
Once it finds that minimum element, it swaps it with the element at the very beginning of the unsorted section.
So it puts the smallest remaining item into its correct final position.
Exactly. In the first pass, it finds the overall smallest and puts it at index 0. In the second pass, it finds the smallest in the rest of the list from index 1 onwards and puts it at index 1.
And so on, selecting the minimum and placing it correctly.
Yep. It repeatedly selects the smallest unsorted element and places it at the end of the growing sorted section, which is at the beginning of the array.
Let's look at the pseudocode from the notes for this one.
Okay. Input, array A of n numbers. Outer loop A goes from 0 up to n2. This A marks the boundary between the sorted part left and unsorted part right.
So A is the index where the next smallest element should go.
Correct. Inside the outer loop, we assume, just for a starting point, that the element AI is the minimum in the unsorted part. We store its value in mine and its location I in lock.
An initial guess.
Then an inner loop J starts from the next position, I plus 1, and goes all the way to the end of the array, N1.
Scanning the rest of the unsorted part.
Right. Inside this inner loop, it compares AJ with the current mine. If age is smaller than mine, we found a new minimum.
Update time.
We update mine to AJ and update lock to J.
So after the inner loop finishes, lock holds the index of the true minimum element in the unsorted section, AI through AN1.
Exactly. Then there's a check. Was the location lock we found different from the starting position I?
Meaning, did we actually find an element smaller than the one at AI?
Yes. If lock is not equal to I, it means the minimum wasn't already in the right place. So we perform a swap between AI and lock.
Putting the found minimum into its correct spot at index I.
Precisely. The outer loop then increments I, and the process repeats for the next position. Once the outer loop finishes, the array is sorted.
The example in the notes uses 514362. It shows finding 1 first and swapping with 5 fit.
Right.
Then finding 2 in the remainder, 54362, and swapping it with the 5 fit at index 1.
It clearly shows that selection process pass by pass. The sorted part grows from the left.
And again, there's a C++ snippet mirroring this logic. Nested loops, finding the min index, and swapping.
Yes, it translates the pseudocode directly into executable C++ player.
Okay, now we're getting into the faster algorithms, the divide and conquer ones. Let's start with merge